Good afternoon, and welcome to today's Machine Design webcast. Our topic today is 5 key reasons to specify flat wire wave springs, sponsored by Rotor. I'm Steve Moraz with Informa's Design, Engineering, and Sourcing Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow help icon below the slides. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your question into the question window on the side of your screen and hit the Submit button. Also, please be aware that today's session is being recorded and will be available on the Machine Design website within the next week. You'll be notified by email when the archive is available. You may also download a PDF copy of the slides by clicking the green folder icon in the toolbar beneath the slides. Now let's meet today's speaker. Jane Nossen graduated from Rutgers University School of Engineering with a bachelor's degree in mechanical engineering. He has worked for Rotor for over 5 years as a technical sales engineer, reviewing prints and coordinating between production, customers, and customer service representatives. He is also a lead contact for OEM customers for Rotor. In his spare time, Jane is an avid cyclist and woodworker. Jimmy O'Shea has worked for Rotor a little over 2 years. He holds a Bachelor of Science degree in Mechanical Engineering from Rutgers University and an MBA in Entrepreneurship from the University of Arizona. In his spare time, Jimmy enjoys playing basketball and the occasional round of golf. Now let me turn things over to our presenters. Jay, the floor is yours.
All right. Thank you, Steve. As Steve mentioned, my name is Jay Nossen. Jimmy and I are technical sales engineers at Rotor. At Rotor, technical sales engineers assist customers with initial designs, print review, product selection, and pricing. We work closely with OEMs and distributors and help select the correct part for your application. Today, we'll start with a quick overview of Rotor as a company, and then Jimmy will dive deep into the wonderful world of wave springs. We'll then have some time for Q&A, so if a question comes to mind during the presentation, you can type it into the Q&A screen, and we'll do our best to answer all of your questions at the end. So Rotor was founded in 1957 by Robert Slass. He was what some would call a mechanical genius, fixing and just doing whatever he needed, paving his own parking lot when he needed to. And Rotor has kept that lean spirit this whole time. We're now a 400-plus employee company with locations throughout the world. Our main manufacturing facility and headquarters is located in Somerset, New Jersey, right here in the USA. And we also have warehousing and production in the Czech Republic. Additionally, we have warehousing locations in the United Kingdom and in China, and sales offices in those locations and Germany as well. Rotor has many quality certifications, which we'll touch on in a few slides. Rotor is a vertically integrated company, from rolling our own wire to designing our own tools and everything else required for ring and wave spring production. We even do our own marketing and sales in-house. This vertical integration helps us control lead times, allows us to offer lower prices and lower minimum order quantities on products, and since we see the product being manufactured from start to finish, gives us quite an advantage in quality assurance. Rotor does offer a complete product line, including the wave springs that we'll be discussing today. We also offer constant section and spiral rings. Additionally, we offer tapered section rings and other stamped products. And we also offer a few lines of hose clamps. Depending on what your application is, we hope we can have a product that can help you get it done. So Rotor Clip has many certifications, IATF 16949 for the automotive world, ISO 9001, AS 9100, and ISO 14001. The pictures here is some of our quality equipment, including a view of our quality lab with a salt spray chamber, a spring force tester, a Keyence vision system for measuring rings, and a microscope that we use for our cleanliness evaluation. Rotor Clip does have an in-house clean room and can perform VDA 19 cleanliness reviews. We do not offer cleaning in-house, but we do have the ability to test our parts to determine what level of cleanliness they attain. The wave springs that we'll be discussing today, we make them in sizes from 3 millimeters up to over 600 millimeters. For those in the inch world, that's a little under 1/8 of an inch to 25 inches. And if you look at that picture in the lower right, that's some of our bigger products. Some of our smaller products are to the right of the red object there. That's a pen. And actually, those small wave springs are no longer even the smallest we make. Our current equipment can actually go smaller than the springs that are shown there. I'll now pass you on to Jimmy, who will handle the meat of today's presentation.
Hi everybody, this is Jimmy. So one of the advantages of a wave spring is that it's actually coiled. So a coiled part is typically higher priced since each piece is coiled one at a time versus a stamping process, which can produce multiple parts at a time. What you're paying for is quality and performance, since there are a number of advantages to the coiling process. As Jay mentioned, we're vertically integrated and we roll our own flat wire in-house, so we control the quality throughout the entire production process. And since we're not cutting through the material grain, the microstructure of the material stays intact. By keeping the microstructure intact, our single-turn wave springs are able to withstand higher axial loads compared to a stamped part. The tooling for each part is matched to the wire size, which allows for quick design changes, often without any additional tooling requirements. So rolled flat wire with radius edges reduces the risk of damaging mating parts in your application and eliminates extra processes such as tumbling or grinding to remove sharp edges. So the majority of our wave springs that we sell are either carbon or stainless steel, and we'll go over specialty materials a little later on in the presentation. Single-turn wave springs with flat ends are especially useful for preloading bearings or if you have a mating surface made of a softer material. As shown at the top right, the sharp corners at the cutoff area of the standard single-turn wave spring can scratch the bearing surface as it is compressed. Over time, this can create debris, which can cause the bearing and or the application to fail. Rotor Clip's patented design with flat ends significantly reduces the amount of wear on the mating surface. This design is especially useful for wave springs with tall waves, since the taller the wave, the more prone it is to digging into the mating surface. Previously, the only option to reduce wear was adding shim ends or flat coils to a multi-turn spring. So this exclusive design saves material, which means lower cost to you and less wear on the mating surface. So one of the other advantages is space savings. So we get the question all the time, why should I switch from coil springs? In many applications, wave springs can offer the same force as a coil spring while being half the height. When designing a housing or bore for a spring, it can be up to 50% shorter by using a wave spring. Secondary operations such as grinding the ends flat on a coil spring are not required. And again, we can switch from a disc spring or a Belleville washer as well, and basically the disc springs have a larger cross-section. So if you're looking for additional clearance for shafts, wave springs save space in the radial direction while providing comparable forces. In addition to saving space, wave springs can also simplify assembly and installations, improving your quality by reducing complaints and rebuilds. Many power transmissions or fluid power systems use a stack of wave springs. The configuration requires the assembler to use the correct number of springs and install them in the correct order. The entire stack can be replaced with a single wave spring for a simpler, faster assembly process. For bearing preloading, a wave spring can replace a spring and retaining ring. And a multi-turn wave spring can be used in place of multiple coil springs in mechanical seals and clutches. For soft mating surfaces, we offer shim end wave springs, which eliminate the need to place a washer underneath the spring to protect the mating surface. It's not always necessary, but it can save you material and lower your cost. When a coil spring is compressed, it also wants to twist. So this torsional movement can wear down the mating parts over time. Wave springs help eliminate this problem since the bending load in the waves guarantees 100% axial transmission of the load. Wave springs produce a more consistent force across a wider range of deflections. The wave spring deflection curve, shown here in red, has a wider, flatter, linear force region compared to a coil or disc spring, which are blue and green respectively. The wave spring tolerance on spring rate and load can be up to 50% tighter than stamped wave washers or disc springs. We can design a wave spring that aligns with your application's desired range of motion and load requirements. For single-turn and nested multi-turn wave springs, we're targeting deflections between 30 to 70% of the free height. For multi-turn wave springs, we target deflections between 20 to 80% of the free height. And we can control the load and deflection by using different size wires, change the number of turns, the number of waves per turn, etc. A stiffer wave spring can be made simply by increasing the wire thickness and/or section, or decreasing the number of turns, or increasing the number of waves per turn. Conversely, we can make a weaker wave spring by thinning out the wire thickness and section, increasing the number of turns, or decreasing the number of waves per turn. In addition to precisely controlling the loading conditions, single-turn wave springs can help simplify assembly. We can alter the design to cling to the housing or the shaft. So whether you're mounting something vertically, at an angle, or overhead, the wave spring will stay in the proper position. We realize that every application has its own set of requirements and challenges, and we specialize in custom wave springs. We'll work with you from start to finish to get you the right tool for the job. This quote form is included in the WaveSpring brochure, which is available for download on this webinar. Alternatively, you can go to rotorclip.com for the digital version, which can be filled out and submitted online. Our standard material is high-strength carbon steel, which is oil-dipped to protect against rusting for an extended shelf life. We offer a variety of materials and finishes to provide options that best fit your budget and specialized application. For more corrosion resistance, we have stainless steel, such as 17.7 and AISI 302, which is always standard or stocked. For seawater environments, we recommend either 316 or Hastelloy. And if you're dealing with highly corrosive hydrogen sulfide, we even have Elgiloy and Inconels. Inconels can also be used for high heat applications up to 1300 degrees Fahrenheit, depending on the grade. We have both the X750, which is good for up to 700 degrees, and the 718 is what goes all the way up to 1300. High heat applications might also call for A286 stainless steel. And if you're looking for a non-magnetic material, we offer beryllium copper and phosphor bronze. For stainless steel, passivation is optional to further protect the material from oxidation and corrosion. So some of the applications that we see are in the downhole tools. So in the oil and gas industry, a multitude of downhole tools can be used at a long distance from the surface. By replacing a coil spring with a wave spring in the anchoring device behind the tool, the assembly becomes more compact and the wave spring offers a more consistent load during the required travel of the tool. Since the tool often sees high temperatures and pressures, these wave springs are typically made with specialized materials such as Elgiloy and Inconel. And then if you're looking to design a more compact and easier to assemble mechanical seal, one wave spring can replace the entire array of coil springs. The wave spring helps save axial space by providing the same load as the coil springs at a lower work height. Switching to a single wave spring not only simplifies the assembly process, but also reduces the number of manufacturing processes, since no additional holes are needed to be drilled into the periphery of the seal housing to secure the coil springs. You can also use coil springs in a fishing reel. Because wave springs require half the axial space of equivalent coil springs, fishing reel assemblies can save both on weight and space. The reel's drag system acts as a slip clutch, allowing the fishing line to slip instead of breaking under the pressure of a sudden pull of a big fish. A wave spring helps control the amount of resistance required before the line slips better than a coil spring, thus allowing a seasoned fisherman to finely tune the drag settings. So wave springs and wave washers can also be used for bearing preload. Preloading a bearing with the proper load will provide system rigidity, reduce vibrations, and optimize the bearing life. The advantage of wave springs is its ability to provide a more consistent spring rate compared to coil springs. Precise preload can be achieved with either a single or multi-turn wave spring. A wave spring can also be used to hold a filter in place for a centrifugal pump. A disc spring was used previously, and its thick radial section was interrupting the pump's throughput. The larger inner diameter of the wave spring allows improved throughput without sacrificing performance. Wave springs can be used in place of coil springs or stamped wave washers in quick connect assemblies. Wave springs provide a low load tolerance of plus or minus 10% to guarantee enough force to maintain a safe connection. Utilizing a wave spring can reduce the overall assembly size since it can be up to 50% shorter than a coil spring while providing up to 30% more travel. If you're currently using a stack of wave washers, switching to a single wave spring will simplify assembly and save radial space, which can help decrease the overall size of the quick connect. So we'll take a quick moment here to ask a poll question. So do you have any applications where a wave spring would be beneficial? Maybe you work with some of the applications mentioned, or there's a project you're working on that requires tight spring tolerances or a more compact design. So we'll give you a moment to answer that now. All right, let's go over a couple more applications for the automotive industry. A wave spring can help provide selective rotation on the side view mirror. The tension is strong enough that the mirror won't rotate due to light forces such as the wind, but allows some rotation to avoid braking should someone bump into the mirror. On the fluid power quick connect, this one's very similar to the quick connects on the previous slide, and a more compact fluid power quick connect can be achieved by utilizing a wave spring to save axial and/or radial space. The exhaust sensor preload is also one of the applications. So the high temperature experienced by the sensor can cause the metal housing to expand. Since the ceramic sensor doesn't have the same thermal expansion properties, a wave spring can be used to prevent movement of the sensor, eliminating unwanted noise and providing more accurate readings. So before we get into the Q&A section, I wanted to basically go over the results. So it's great. Almost 2/3 of you have a need for a wave spring. So we'd like to get some more feedback from you on that. And then we'd like to thank you real quick before we get into the Q&A section for your attention here, and then we'll open it up for Q&A.
All right, a few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. While we are answering your questions, please complete the feedback form, which is located on the bottom of your screen. Okay, the first question. Someone's in a hurry. They want to know, what is the turnaround time on stock items?
So the turnaround time for stock items is 4 to 6 weeks.
Okay. How much would it be for a custom item?
So if it's a custom item, it'll be about 8 to 10 weeks if we have the material on hand, or it'll be 10 to 12 if we need to get the material and the tooling created.
Okay. What are some of the types of exotic alloys you have in stock?
So some of the exotic alloys we have in stock are Hastelloy, Inconel, and
okay. The others?
Jake can speak a little bit more on that one.
Okay.
So in stock, we do have a good selection of Inconel X750 wire sizes. Usually for some of the more popular sizes of wave springs, say in the 1/2 inch to 4 inch range, we'll have a good amount of material that we can use in the Inconel range. Above there, we have select sizes, but one of the nice things about wave springs is there's multiple ways to make them. So if you're looking at a 5-inch spring with a certain force, we can make it out of a wider material, or we can make it out of a narrower material but increase the wave height. As Jimmy was mentioning when he talked about the multiple ways to make a spring. In terms of other materials we have on hand, 316, 302, 17.7, and carbon steel are our most common, and we're usually pretty well stocked on them. The other exotics, Elgiloy, Hastelloy, we don't stock them until we have a use for them, but then if you do place an order for a part that requires that material, we will usually then stock not a huge amount, but enough for if you came back with another order, we wouldn't then have to reorder material. One of the nice things about being privately owned is that we don't have to answer to quarterly stock reports. So we have large warehouses full of raw material, and we buy when the market's low, and we hold it, and then when the market price goes up for material, we use the material we have in stock and hopefully make it through, any minor increases in steel price or stainless price, but still offer a great price to the customer. The original question that was asked before I went off was what exotics we do have in stock. I mentioned the X750. We also have a good selection of A286 in stock, which is a high temperature application stainless. Gets up to around 1300 degrees without softening or big changes to its material properties. Do we have any other questions?
We have another materials-related question. Are your wave spring RoHS compliant? RoHS.
So RoHS compliance, for those of you who don't know, is the restriction of hazardous substances. All of our material is RoHS compliant. On some of our tapered section parts, we offer cadmium or zinc finishes that are not RoHS compliant, but as wave springs aren't easily plated with cadmium or zinc dichromate, for example, as a general rule, every wave spring we manufacture is RoHS compliant.
Okay. What is the size of your engineering staff, support team, I should say?
So our tech sales group there's 6 of us in the U.S., and we have 1 tech sales person working out of the U.K. In the U.S., our engineering staff is a good question, but we have a decent team focused on different areas. Some of them are focused solely on designing parts and making sure our dies and stamping equipment works. Some of them are focused solely on finishes, plating, heat treating, making sure the factory runs, and then some of them are dedicated solely to tool design. In the Czech Republic, we have similar staffing for design of tools and maintenance of our facility there. And then our sales staff in Germany, one of our sales staff there is very well acquainted with wave springs and is actually one of our most knowledgeable people on wave springs.
Okay. How do wave springs compare to coil springs in terms of cost?
So if you want to answer solely one spring versus another spring, the wave spring will be more expensive 90% of the time. The cost savings come from the reduced application size, making it smaller housing, or removing a secondary operation. For example, on a really large coil spring or even a smaller coil spring, a lot of times there's a secondary operation involved to grind the ends of the spring so they lay flat against the retained surface or the mating surface. And there's also, as we saw in the applications that Jimmy was reviewing, an example of the mechanical seal, where the overall package complexity is decreased. You're not having to drill for individual springs, and you could use one wave spring. So that one wave spring is more expensive than the 12 coil springs, but the overall application is a lot less expensive. Likewise, with the downhole tool, the performance of the wave spring is beneficial compared to the coil spring. So downtimes are are reduced, and when you're in the world of oil and gas, time is money. So saving an hour of time saves you, who knows, thousands of hours or thousands of dollars.
Okay, a similar question. How do wave springs compare in cost to Belleville washers?
So the cost savings there is actually from a quality standpoint. Belleville washers are a stamped product, so generally they're less expensive than wave springs. But if you're using a Belleville stack where you have, say, 4 or 5 Belleville washers and they have to be all installed in the application and they have to be installed in the correct orientation, you leave one of those out and no one notices it, now you have a quality callback. You may have to tear down an entire engine or an entire application to fix it. In the process, you may even destroy the entire application. We've all had that situation when we're working on the car where we wind up with 1 or 2 bolts left over, and you just hope they're not coming from somewhere useful. Imagine that on your assembly line, and at the end of the month, you have extra stock, and that wasn't supposed to happen. So now you may have a quality freeze on an entire lot of products. So the cost savings versus is in the quality department.
All right. What are some of the custom capabilities for wave springs?
So custom capabilities is more custom capabilities. You're looking at wave springs working compression only, so you're not going to see some new design that has a wave spring being expanded. But the custom applications are really up to the customer and what they can come up with. Our design team works to make your application work. We try not to over-design anything. We give you the part you need in the time frame you need it. Not sure if there's a specific question or a specific example that the questioner had in mind, but feel free to throw us another question.
Okay. What is the greatest axial load wave spring that you have ever made?
So the greatest, that's not something I know offhand. We've done, that is something we could look back in our records. I know we go well over 1,000 pounds. Some of the examples where that high strength is, or where that high axial load is found, is in a nested wave spring, where instead of going crest to crest, you're lining up the waves, so you get a very short wave spring, but a very strong application. And I've worked on items in the 1,500 pound range there in about a half inch of space, or half inch for the work height, and that was on a valve application where I think it was a 6-inch valve, and you needed a really good force to hold the valve components in place.
Okay. How are wave springs delivered or packaged without them becoming wedged into each other or tangled? So
the wave springs themselves, some of them we do offer in shrink wrap stacks, especially the single turns can be offered that way. The multi-turn wave springs, stacking them is less beneficial because you throw 5 pieces in a stack and now you have a stack that's 5 inches long and can't really add too much more to that. For reference, when we stack tapered section or other flat parts, we're looking usually at 50 to 250 pieces per stack. One thing we do find, though, I did a little work on figuring out box sizes for wave springs before we manufactured them, and I tried to find the packing efficiency for the boxes, and I went down to our warehouse, pulled a bunch of existing stock to test, and found that they didn't really want to tangle up too much, the multi-turns, because the ends are closed, the waves are, they're closed. It's not a coil spring where things could slip in between each other. So even if you do get a bit of tangling on 1 or 2 parts, they come apart immediately because they're not twisted together. They're just a little bit of overlap, and they separate, just like, I don't know a good example of something that separates.
All right, a similar question. Are there any difficulties in automating the installation of your springs?
It does depend on the application. Since we're not stacking these springs, since we're not stacking them, you sort of have to figure out a way to feed them into an automated assembly equipment. Beyond that, every application is different. So you may be able to work with a funnel to drop the spring in there and drop it into position, or there may be a better process for doing that. Rotor Clip does not design automated assembly equipment, but we can help you with figuring out the best way to approach the automated assembly.
Okay. Is there any way to prevent slippage or separation on a nested spring at high RPMs?
So on a nested wave spring, I assume this is a shaft operation, but as the RPMs increase, I wouldn't expect too much separation, especially if the spring is under load, because the axial load being applied to the spring would hold the waves in position. I guess if the spring came out of axial load, you might see a little bit of an effect, but honestly, that's not something I've ever come across. If there's a specific application in mind, you can definitely reach out to us after this webinar, and we can talk more specifically about the application in question.
Can you make progressive rate wave springs?
So one of the nice things about wave springs is the linear spring rate. I don't believe a progressive rate is possible. Once you go out of that linear region, you will see a little bit of a rate change, but that's also causing overcompression in the wave spring, which will then affect the spring once it returns to that linear region. Basically, you've now changed the the spring profile of the wave spring. So, short answer: progressive rates are not possible.
Okay, this sounds like one of my questions. Does Rotor Clip offer free samples?
The Rotor Clip offers free samples on stock parts. If you're looking at a custom design, we cannot offer free samples, but we can offer low volume prototyping, depending on the eventual project and depending on the size of the ring. That could be anywhere from a 5-piece minimum to a 100-piece minimum, and that's the nice thing about wave springs is we have all of our wire sizes in stock and the tooling that matches up to those wire sizes. So we designed the wave spring based on an existing wire size. That saves the customer time, saves you time on lead time, saves you cost because we already have the wire, so you're just paying for the wire you use, and we already have the tooling, so we manage to basically make the spring, since there's multiple ways to design one, we make the spring out of existing tooling and wire, allowing for low-cost prototypes when we can't offer a free sample. We do have full catalog lines of single-turn and multi-turn wave springs, both metric and inch. So if you are looking at a application where you would be interested in a free sample just to try something out, start with those products, and as long as they're not huge, if you're looking for a 2-inch part, 3-inch part, samples are readily available. 15-inch catalog part less likely to be in stock, and we might have to charge you for a piece or two there.
Here's sort of an open-ended question. Is there anything on the horizon for new materials, new types of rotor clips, new shapes, new applications?
So Rotorclip did just purchase a new machine that will allow us to get down to 3 millimeters and possibly below that on wave springs. One of the problems we're finding now is sourcing wire for parts that small, but we hope to have a wire supplier that can help us out with that, and basically that size we're looking, we're hoping to get the medical device and the medical industry as a partner at Rotorclip, helping them with their applications as they're going smaller and smaller with their designs. We're going smaller and smaller with what we can do to help them out. Wave springs is one of those interesting places where making it bigger is a lot easier than making it smaller.
Okay. That's all the questions we have from our viewers. So that will conclude today's presentation. On behalf of Machine Design, I'd like to thank Rotorclip for sponsoring today's event, and of course all of you for joining. Have a great rest of the day and a great weekend.